So in this video, I'm going to show how to work on 2.6 LRS 151, 152, and 153. So we'll show our conclusion. Our conclusion is not Q, so we'll make an indirect assumption, and we'll go ahead and assume Q. And now we'll bring in our premise. Well, the derivation is stuck, and what do we do when our derivation is stuck? We do a subderivation. What subderivation should we do? Well, there's that not if p then q on line 3, and we need to do something with it. And right now, we don't have any inference rules that apply to not if p then q, but if we get if p then q, then we can apply id to 3 and 4 to box and cancel. So getting if p then q would be really nice because it would, on the one hand, it would complete the derivation, and on the other hand, it's the way to use 3. Well, we don't have if p then q, but we can try to show it. So we'll assume CD. Now, how do we box and cancel line 4? Well, we need the consequent, which is Q, which is what we have on line 2. So we'll bring it down, and we'll apply CD to 6, which will box and cancel line 4. And now we can do the ID that I just showed. And we're done. So this is just, you have to recognize, okay, I'm in a derivation that's stuck, and it has a negated conditional in it. What should I do? Show the conditional. And then, oh, well, I actually can show the conditional very easily because I already have what I need to box and cancel it. So there you go. That's what you need to do this problem. Let's take a look at 152. So again, we'll say show the conclusion, and we'll make an assumption. Let's do an indirect assumption. It has to be not P. We bring in our premise. We're again stuck, just like in 151. So what should we do? Well, again, we need to do a subderivation. Because there's a negated conditional in our derivation, we should do a subderivation of if p then q, because once we complete this subderivation, we'll apply id to 3 and 4. Let's assume p. Now, if we look at once we've assumed p, can we do anything? There are no rule applications we can make, and so you might think, let's go ahead and show consequent. That's what we do when we're trying to show a conditional and we're stuck. But in this case, that's a bit hasty, because line 5 contradicts line 2. And that means we can apply ID. We can bring down line 2, and now we say, aha, on lines 5 and 6 I have a contradiction, and that's what I can use ID. I can apply ID to those things, and they will box and cancel my show line. So 4 cancels. Once 4 is canceled, we can use line 4, and it itself contradicts line 3, so we can apply ID again, this time to 3 and 4, and that will box and cancel line 1. So this 2 is now complete. Again, I'm stuck and I have a negated conditional. Let me try to show the conditional. Okay, I make my assumption. Oh, look, there's this funny little contradiction move I can make, and that gets me this. Good. Okay. So let's look at 153. So again, we'll show the conclusion. We'll make an indirect assumption. Now let's look at our two premises. Then there's no third premise. Okay, so here, what's going on? Well, we have a stuck derivation because we don't have what we need for modus ponens or modus tollens with line 4, and we can't apply rules to line 3 because it's the negation of a conditional. So we're stuck, and we should do the same thing we've been doing. We should show if P then Q. Whenever we have a negated conditional and we're stuck, we should try to show the conditional. Okay, so let's assume CD here, which gives us P. Let's see, can we use P? We can. We can use it with line 6. So we'll say 4, 6 modus ponens. And that gives us, if not Q, then R. Well, can we use that? Yes, because negation R is the negation of the consequent of line 7. So I have a conditional on line 2, the negation of its consequent on, I have a conditional on line 7, the negation of its consequent on line 2, and that means I can apply modus tollens to 2 and 7, giving me not Q. What can we do with negation Q? Well, Q is the consequent of line 5. So if we get Q, we can box and cancel, and we can get Q by applying double negation elimination to line 8. So now we have Q, we can apply CD to line Q, to line 9, Q, which will box and cancel line 5. 5 and 3 contradict each other, so we can apply ID to lines 3 and 5, and that completes the whole derivation. So in all of these, when we have a negated conditional, we have to notice that we have, once the derivation is stuck, we have to notice that we have a negated conditional, and then know what do I do with that? I show the conditional. And how do we show a conditional? We write out show, we write show and then the conditional. We make a conditional assumption, and we may need to do show consequent as well. We didn't in any of these. So those are those three problems.